Now it's turn to learn more about astronomy module from Spyridon Kokkotas from Research Path in Greece. Yeah, sure. And here we are.
Are you having the presentation or do I?
Yeah.
Which one is it? Okay. Hello, good morning everyone. I'm Spyridon Kokkotas. I'm from Greece and I represent an SME called Research Paths who has developed the astronomy course. Oops, there we go. Now, nope. Okay. What we have done is that we have developed a course of astronomy that consists of 10 lessons. This is a complete course. The idea basically was to make a course for 15, 16-year-old students, which basically covers the level of knowledge that is needed for someone to be able, to follow it. Obviously, it can be done by someone with higher level knowledge or adults or anyone who's interested but has some background knowledge on science. Now, we have divided this into 3 thematic sections, which is some kind of an informal classification, but nonetheless it exists. First of all, we've made a general introduction to astronomy, basic astronomical subjects, which start from our theories about, the universe, which basically focuses on the geocentric and the heliocentric models, Copernicus, Galileo's, etc., etc. And we give some information about the sun, the solar system. Then we go to the application of astronomy, which is the far more interesting and technological part, which has to do with space travel, satellites, and we also have a lesson for the greenhouse effect. And this is basically where it's mostly connected to STEM careers, because we try to show, for example, that in order to make a space mission, there's a huge variety of professions that are involved, and then you need a combination of skills and competences in order to achieve that. And finally, we've made another section which is more theoretical but far more interesting from an educational, at least from my point of view, that we've used astronomy, and because it's a par excellence interdisciplinary discipline, to teach some basic epistemological notions to children. For example, we used Kepler's law to introduce the children to the notion of what scientific law is. And we also used gravity in order to explain some basic notions of the scientific method. And finally, we made them do it themselves in the sense that we asked them to go collect data and interpret them. This is the final lesson of the course. For this, we used a drone. And as it was the lesson was a bit playful, it was a huge success. Children loved it. They saw it as a game. Now, what did we try to do? What did you do? What's new about that? What's the big deal? Perhaps nothing, perhaps much. Basically, what we had in mind, what we tried to do, was the following. just I forgot about this, but all the lessons, it's a little bit about the structure. We have a teacher guide, a worksheet, a presentation, but the teacher does not do the lesson based on the presentation, it just follows it. It's just help children focus on the course of the lesson. It's some kind as a constant reminder there. And an evaluation sheet so that we see what they did with the lesson. Yes, that's about it. And methodology. As it was written in the application, as we were obliged to do, we followed a basic structure of inquiry-based learning, which was a mixture of open and structured inquiry learning, combined with elements of constructivism. And we have written the methodology in all the teaching scenarios so that it's clear for the teacher and whoever does it so that he knows or she knows what he's doing. Now, let's go to what I had started saying before. This is what we try to do. So what's the big deal about this lesson? First of all, we try to do a STEM astronomy lesson, something at least which to our knowledge had not been done before. So the idea was to use an interdisciplinary approach to teach astronomy, teach science, and this was helped a lot by the fact that astronomy is by its nature interdisciplinary. Now, we also, as I told you before, try to teach epistemological notions through astronomy. What is more interesting, to cut a long story short, is that we try to show that astronomy is not something arcane, it's not something very difficult, it's not addressed to extremely intelligent people. This is a misconception, very common one, which is exactly what I said before, it's a misconception. We have tried to show that astronomy is based on simple principles of mathematics, physics, chemistry, and that's what we basically use. What we have tried to show is, and especially we tried this in the technological applications, when we showed the technological applications in the satellites and space travel, is that even the most advanced technological instruments are based on very simple principles. And in this respect, we made a robotic vehicle, which is like a toy, no bigger than a toy, which is a replica. It replicates the function of space vehicles, which is something that can be very easily constructed and you can find it in a shop. So we try to show it's not something arcane, it's not something very difficult. Astronomy, in a basic sense, is in your house. You can experiment with astronomy, with materials that you find in your kitchen, and we have exactly some experiments like this. Also, we introduced a bit of STEAM, an artistic part in the lesson, in the sense that we applied storytelling. I don't know if you've heard about storytelling and its combination with science, but basically we used narratives to put scientific topics in context, because we wanted to develop emotional understanding, motivate the children, and help them better to understand the scientific content. For example, to give an example how we put it in context, for example, we made a narrative about travel in space. It starts from the quest to reach the star, but it puts the race for space in its historical context. For example, it makes clear that the race of space for space was something that happened in the context of the Cold War. And this helps children to contextualize science, which for our opinion, this is quite important. Yes, and that's about it. I have nothing else to to say. Thank you very much.
Thank you, Spyridon Kokkotas, for the overview of astronomy modules. Thanks a lot.